From the Library of Congress in Washington, D.C.
Our speaker this session is Harold Varmus. It's hard to know how to describe him, although the first appositional phrase would almost certainly be 1989 winner of the Nobel Prize in Medicine or Physiology. As readers of Dr. Varmus's autobiography of last year, The Art and Politics of Science, know, or barring that, readers of last Sunday's Book World section in the Post, our speaker came to science quite indirectly. The son of a physician, he went to Amherst College, where he was an English major who also took all of the pre-med curriculum. He opted to pursue English, went to Harvard to get a doctorate, but dropped out when he felt the siren song of family expectation and practical usefulness draw him back to medicine. He may have been one of the few people who sat his parents down, told them he was going to medical school, and saw their faces drop. What happened to our son, the English prof? He went to medical school, but he didn't go into medicine. Instead, he went into science, which is quite a different enterprise. He learned to talk the language of science late, and perhaps came to it with the insight and daring of a non-native speaker. And he barged right into the most heated conversation. What is the relationship between genes, the repository of our permanent biological identity, and cancer, the disease of wild and fatal innovation? He and Michael Bishop found part of the answer in oncogenes. They are the virus-like remnants in our DNA heritage that can, under certain circumstances, be awoken to produce uncontrolled cell growth. The modern understanding of cancer, and someday much of the therapeutics, will owe their a debt to him. Dr. Varmus went on to become the head of the National Institutes of Health during the Clinton years, and later the head of the Memorial Sloan-Kettering in New York. He recently accepted President Obama's invitation to become the director of the National Cancer Institute, which I guess is a little bit like William Howard Taft becoming Chief Justice after being president. He's also a big bicyclist. One day on vacation in France, he got up before breakfast to go for a ride and ended up in another country, Italy, I believe. Please welcome Harold Varmus.
I want to begin with a couple of thanks, not just to the Library of Congress and the Washington Post, which have been thanked many, many times, but I want to thank Michelle for bringing my message to those of you who have hearing problems. And I want to thank my friend David Brown, himself a physician and a distinguished science reporter, for his very deft introduction. I also want to thank all of you. I've been sitting around listening to people all day, and I'm about worn out, so your endurance is great, and thank you very much for those of us who are backloaded on the program for you to have stayed around for us. Now, unlike most of the other speakers you've heard from today, I don't call myself an author, except possibly on days like today. And I am now, above all else, a scientist. When I'm asked at immigration, what do? I don't say I write books. I say I do science, or I'm a government official. I'm also a lapsed physician, and I run some institutions. But, of course, like most academically based scientists, I've done a lot of writing, usually in my own fields of cancer research and virus research. But, like many other speakers you've heard from, I aspire to be an author. And last year, to give myself legitimacy in this role, I did publish a book, as you've heard, about my life in science and politics. How did that happen? Well, in 2003, a friend of mine, the noted biographer Gene Strauss, who runs a program in the humanities at the New York Public Library, asked me to give a series of lectures called the Norton Lectures to talk to humanists about science. Initially, she wanted me to talk about C.P. Snow's Two Cultures. That idea seemed a little worn out, and I put together 3 lectures on becoming a scientist, doing science, and being a scientist engaged in politics. I gave the lectures, that was fun, 2004, and then I read the contract. And the contract said that after the lectures are given, a book will be delivered to Norton, after which a check will be received. So that, you might think, would be a strong motivation, but indeed it took me 4 more years to write the book, because unlike one might have anticipated from one's initial reaction to a contract like that, you can't simply take 3 lectures and put them into a book. Books take a lot more work and a lot more depth, and indeed, after a lot of procrastination, I tried to give it that kind of depth. Now, my motivation to put the lectures into a book form was not simply based on the idea of getting a modest check from the Norton Publishing Company. Indeed, as I thought about it, I realized that the country needed, at least those who might be readers of this book, could profit from a better explanation of what human motivation and trials and tribulations lie behind the science that people read about when David Brown and others report on it. I was also concerned that despite the fact that this is the age of Obama, I stood here on Inauguration Day and heard the new president declare in his inaugural address that he was going to restore science to its rightful place, that science was one of the few ways we had to deal with the chronic and acute problems of our society: disease, environmental degradation, lack of energy sources, and difficulties in our economy. And I believe in that, and yet I am concerned that for most people, science remains an abstraction, not a human activity, and in particular, not a human activity with moments of drama, frustration, exhilaration, and that as a result, for people who don't understand this, science and scientists are mysterious and remote, not an exciting realm of activity carried out by real people. This notion, very nicely expressed by my new friend Richard Holmes, the British author who was speaking in a tent a few blocks away, hence my sweaty appearance in front of you a few minutes ago, who in his book, The Age of Wonder, a book about science and the arts in the late 18th and early 19th century, said, as a means of explaining why he wrote the book he wrote, that it's now important to understand how science is actually made, how scientists themselves think and feel and speculate, and we need to explore what makes scientists creative as well as poets or painters or musicians. So there are lots of ways to tackle this problem, and indeed there are now movies. There's even a recent opera, John Adams' Dr. Atomic. There are books like Richard Holmes that describe histories of science, how the atomic bomb was made. Some of you just heard that from Richard Rhodes, The Eighth Day of Creation, and others that I won't bore you with. There are biographies, that is, books written by authors about famous scientists. One I like particularly is a book by Lisa Jardine on the curious life of Robert Hooke, a 17th century scientist, one of the first. There are novelistic treatments of science that are entertaining and often give a picture of what science is like. One of our speakers today, Allegra Goodman, has written a very wonderful book called Intuition about doing the kind of science my lab does. Ian McEwan, the remarkable novelist, has written a recent book about a physicist, a book entitled Solar. And again, C.P. Snow, who I mentioned earlier, has written several good books, including The Search and The Masters. And there's poetry by a woman named Rebecca Elson, an astronomer, called A Responsibility to Awe. My own book, as you've heard, is in the realm of memoir, and here I'm in a realm in which there are giants. The biggest giant in this field is Jim Watson, whose book, The Double Helix, broke the ice in having scientists talk about the work they do. My own emphasis has been focused on 3 broad topics, each of which represents an important aspect of science, and each of which reflects the odd features of my own career. So first, how do you become a scientist? And as you heard briefly from David, I had a torturous path toward science, a path that illustrates the forgiving nature of American society that allows one to have a prolonged adolescence and wend one's way through literature and medicine and eventually on to science. My family background is interesting in the sense that my grandparents escaped anti-Semitism and poverty in Europe, came to this country around the turn of the last turn of the century, and yet in only the course of a few years had children who went to Ivy League colleges, had professional success, and gave me the luxury of being able to indulge my curiosity about many fields. Then the Vietnam War played a role in my transitions because as a physician trained in the 60s, I was obligated to serve my country, which was then fighting a war that I didn't approve of. And I became a member of a corps often called the Yellow Berets, young doctors who often were objectors to the war, who ended up in a wonderful situation being trained at the National Institutes of Health, which has been the fuel of my loyalty to that institution over the last 40 years. At the NIH, I learned what science could do and how engaging it was, and part of that experience is what fuels my current enthusiasm for telling others how wonderful science can be. So that's one part of the story. The second part has to do with the science itself, and here, as a writer who understands a lot of molecular biology, I knew I had a challenge. I've been trying to teach my wife for 41 years what I do in the lab, and I can tell you it's not easy to do that. So I've tried to figure out how I could distill the kind of science I work on into a story that could connect with some basic facts that people know, like the double helix is the shape of DNA, and to try to explain how curiosity about how a virus that caused cancer in chickens could be pursued to understand the fundamental nature of cancer in human beings. And I try to take the reader through a series of steps that reflect both the struggles of doing the work and the current triumphalism that some of us feel about the new kinds of therapies and strategies for prevention and diagnosis that are the result of that work. Along the way, the work was, of course, carried out not just by me alone, but by a partner, Michael Bishop, with whom I shared the Nobel Prize some years ago, and by a number of trainees, all of whom I tried to portray, or some of whom I tried to portray in the book. Finally, I wanted to talk about something that was an unusual experience for a scientist like myself, namely a change into a kind of politician of science. The prize having given me a certain unearned credibility as a spokesperson, I was turned to for opinions and eventually asked to run the world's largest supporter of biomedical research, the NIH. And in that role, I had to learn a lot about budgets and politics that I didn't know before, and set scientific priorities and deal with advocacy groups and many other both supporters and critics. So that whole realm of activity is one that I think is useful for other scientists to know about and for those who respect science to understand. Along the way, as I took on the chores of being the director of the NIH, I was privileged to deal with a number of important issues that have become obsessions for me in the ensuing years, in the 10 years since I've been at the NIH as director. One is the importance of research on stem cells. Another is the means in which we use the internet to promulgate our work and make it more accessible to others. And the third is the importance of using the information we know about research and medicine to try to improve the status of most of the world living in lower middle income and poor countries in a field called global health and global science. Now, I am in the tent called Contemporary, and I want to remind you that some of these issues are just as alive today as they were 10 years ago. Indeed, the world of cancer research, of course, is moving ahead extremely rapidly these days. Three of the big issues that I've mentioned are still in the news. Open access publication is now something which is widely respected and carried out without financial disaster. And Congress has directed the NIH to ensure that all of the work that's carried out with this money ends up in a publicly accessible database within a year. Second, thank you. Secondly, the nation is taking seriously the challenge of improving health in developing countries, and the Obama administration's Global Health Initiative is setting a new standard, extending some very commendable work carried out by the Bush administration in providing remedies for HIV under the PEPFAR program. And as I'm sure many of you know, stem cell research is, while having advanced dramatically over the last several years and having been encouraged by the Obama administration, has taken a real blow with a recent ruling that has offered a reinterpretation of an appropriation provision that now threatens the future of stem cell research. As you've heard, I am back at the NIH as director of the Cancer Institute, and the adventure is ongoing, and with luck, maybe there'll be another book. But thanks very much, and happy to take some questions.
Coleridge, the poet, had a dream that led to his poem Kubla Khan, and as you know, Kekule had the dream about the benzene ring.
Right.
And I was wondering...
That's the snake devouring its own tail.
Yes. About the creative process, is there such a thing that as inspiration in science, and if so, is it analogous to that in literature?
Yeah, so I'm not an authority on the creative process, but one of the things I try to do in this book is to relate how ideas came to me. I don't really understand how it happens, but one important idea that happens to lie in the narrative of the kind of work I did as somebody trying to find cancer genes just popped into my head when I was wheeling my 6-month-old son through a churchyard during a sabbatical in London. And I would say the important thing there is the word sabbatical. Many of my fellow scientists don't take a year off. They just plunge ahead all the time. They're working, trying to get their next grant, publish the next paper. And I think some time to get away from routine work and think more deeply about science is an important thing. I'm in the midst of trying to do an analogous thing at the NIH at the moment. We're in a phase of remarkably dense data generation in the cancer research world. And I've asked a number of my colleagues to come together and think not about the next piece of data or how we interpret it, but let's think about what are the big ideas that we have not been working on that we now could possibly answer. And hopefully out of that process of saying to my colleagues, I know there are a lot of ideas that we really haven't thought much about. For example, we all say, yeah, isn't it amazing Lance Armstrong took chemotherapy for testicular cancer and then won 7 Tours of France. But we don't think very much on a daily basis about why cisplatin actually cures testicular cancer. And I find myself saying all the time, if we can just make cancer a controllable chronic disease, that would be a real step forward, and it would be. But I don't think we should lose sight of the fact that in some situations, and there are a few other diseases as well, chemotherapy does cure cancer. Why does that happen? It's a tough problem to answer, but I think we have tools to try to look at that now. Yeah. Oh, sorry, over here. I'm going to alternate.
My question is about stem cell research.
Yes.
And given that it's an ethical controversy, and isn't it true that we can make any cell pluripotent? We have enough information to do that. Can we not go about it another way? Why not, if not? And is it not a form of slavery if you can own a life like that and do whatever you want with it otherwise?
Well, let me try to answer that question. You're referring, of course, to the induction of what are called pluripotent stem cells, a very important method that may actually be the most important technology in developing therapeutic cells. But I would caution you a little bit about that, because we've only known about induced pluripotent stem cells for a few years. We know already that they are not identical to embryonic stem cells. There are limitations in their potential, very likely. They retain a memory of the kind of mature cell they were. There are probably ways around that, but if you want to compare those cells with the most advanced, the most well-understood primitive cell with maximum potential, I think it is important to carry out comparisons with human embryonic stem cells. Now, I think your other point about enslaving a life depends a lot on what one considers life. And here we have an area of moral argument. But I would point out that what most scientists are saying at this point about the process by which stem cell research is being funded is that what they're asking is that cells derived with non-federal money be used or be able to be used with federal money to do further studies. So there is there's a division that was made traditionally, accepted by the Bush administration and by the Clinton and the Clinton administration too, but also the Obama administration, to allow work on stem cells that have been derived with non-public money, non-federal money. And that, that's an arguable position. I know there are people who feel strongly the other way, but I think that the benefits to human life of working with cells that were derived from small clusters of cells that were going to be discarded anyway makes a lot of sense to me.
Would you say a few words about copyright and the way you can do things over the web, and perhaps even micro-dollar exchanges or something of that nature?
Sure. So I assume you mean in the context of scientific publication. Now, I'm not anti-copyright by any means. I believe that copyright is useful, but traditionally what authors have done, because there really was no alternative, was to turn over copyright to publishers after their papers were accepted and allow publishers to do whatever they like with papers. I think there's another way to do things, and that is to allow the copyright to be held by authors. We're in, of course, a realm this day of authors who make their living by selling their work, and I don't want to stop doing that. That's very, very important. But most of us who are scientists, when we write scientific articles, we're not interested in money. We're interested in fame. We don't get money for the publications we write. What we want to do, we want everybody to read our papers. We want those papers to be not just famous, but read by others and built on, because the scientific process depends on the dissemination of one's work and the greatest possible access by other scientists. So in the world of open access publication, what's done is to allow the author to hold the copyright, not turn it over to the journal, and grant a license to the journal to publish the work, allow it to be used freely for any purpose, as long as acknowledgement of authorship is retained. I think that's a very reasonable position. It's one that's been espoused by many journals, and in the larger world, it's become routine now, at least in the biomedical world, even if one doesn't publish in an open access journal, but in journals that are either for profit or for the sustenance of scientific societies, to allow that work to be placed in a public repository called PubMed Central, housed at the NIH. And that has served the scientific community exceedingly well. I believe the delay of a year is excessive, but the copyright rules there have been worked out, and we've made a big improvement in the way in which we all access scientific literature. Libraries have become smaller. Of course, there's a crisis in university libraries created by the pricing practices of many for-profit journals, and one of the few ways to try to overcome that is by publishing by a different business method, the open access method, which we know works. The open access publishing house that I founded some years ago with my colleagues, called the Public Library of Science, now actually is in the black and doing experiments with the excessive income that it receives from the publication fee paid by the authors, and everything that's published by that group is made instantly available to the entire world for free at the time of publication. Over here.
Because of my personal and family history, I feel that going to the doctor is very important. Having the colonoscopy, in my case, being tested for skin problems because I've had melanoma. Harold, how much is detection and education for preventive medicine? How important is that for the NIH, and what is your priority with that, with the NIH?
I think this is extremely important. And indeed, we know that prevention is often not as sexy. I'm not often asked, when are you going to prevent cancer? They ask me, when are you going to cure cancer? But because there are no grateful people whose cancers were prevented. So screening is incredibly important, and we need to do a better job of that. It's not just the job of the NIH, of course. It's the job of personal physicians. It's the job of the CDC. It's the job of the Department of Health and Human Services more generally. I'd like to think it's the job of the insurance companies, which have a great deal to benefit from preventing disease that becomes very costly. So this is a major thrust in my own administration at the NCI. I think we can do a lot in prevention, both here and at home, and also around the world. We tend to neglect cancer as a threat to poor populations. But the fact is that cancer is a major burden of disease, even in the poorest countries, and there are many things that can be done, whether it's vaccination against hepatitis B or papillomavirus infection, or whether it's reduction in use of tobacco, or early detection of other cancers, simple surgeries, use of those anti-cancer drugs that have gone off patent and become feasible for use in poor countries. So from my point of view, emphasizing prevention and dissemination of what can be done, using the internet to help us out in dissemination is a very important feature of what we see happening in the next 5 to 10 years. Over here.
Okay, I guess my question is, I worked in the lab for a while, and so I understand that there is some good science and some bad science, and so
what do you mean by bad science?
Some science that doesn't follow protocol perhaps as closely as others do, and so the results may be somewhat skewed, and so I see a benefit in having peer review before publication.
Nothing I've said about open access publication has anything to do with peer review. Open access publication is all peer reviewed.
Okay. But I think that the change in funding structure during the Reagan era had some effect on willingness to share data, and I wondered if there had been any sort of study that has looked at how that change in funding structure has had an effect.
Actually, I'm not sure what change in funding structure you're talking about, but I would say that on the whole, the willingness of scientists to share data has increased enormously. And it's increased in part because of the kind of science we're doing, which is much more data intensive. It requires teams much more often. A phenomenon which I think has its own dangers, because sometimes the greatest moments in science occur when a lone scientist is thinking alone about a problem and not working in a team. But nevertheless, there is much more team science, much more interaction among scientists at different institutions. And the nature of the science itself demands more sharing. Now, in addition to that voluntary willingness to do more as teams, the NCI and other institutes of the NIH demand sharing policies as part of grant applications. And I think that we're on a good trajectory in that regard. Okay.
Can you talk a little bit about the funding decisions, how it's decided which programs get funded?
Sure.
And related to that, about publicizing what the NIH does so that you can build support within the community.
Right. Well, on your latter topic, I think we have pretty good support from the American community for NIH and what it does, but it could be a lot more informed, and we are responsible for creating stories that reflect what we're doing, explain to the public more fully. I think the instinct is to support the NIH, because life expectancy in this country has improved. We are the pioneers in the world in generating sophisticated new approaches to healthcare. And I think the reputation of the NIH is strong, but I do agree with you. In fact, I was meeting with a journalist today to talk about how the NCI should sort of recraft its story, so we're not worried day by day about whether we're winning the war on cancer, but instead talking about what has actually happened, how our understanding of why a normal cell becomes a cancer cell can be translated into new ways to prevent and treat and diagnose cancer. So I agree with those points. Your first point was?
About the funding decision.
Sure,
how do you decide which programs get funded?
So let me just, first of all, there is a macro set of decisions. How much does the president ask Congress to give to the NIH? How does Congress decide how much it's going to give to the NIH? And those are issues that we participate in by telling the president and Congress what we could do with more money. In general, Congress and the president and presidents have been kind to the NIH. We're probably among the agencies least likely to have our budget cut in a time of draconian cuts that are talked about by both parties. But what you're asking about is how do we at the Cancer Institute decide which programs to fund? And that's a complicated process. Some of it's determined simply by peer reviewers saying that grant's better than that grant. Some of it's decided by saying, we looked at our portfolio, we're not doing anything on cancer X, and there's a new opportunity. So you've got to weigh the burden of disease, the public health effects of disease against, first, the opportunities to study that disease specifically, and importantly, against the opportunities to make inroads against a certain disease by studying something that may not be obvious to the public. Public says, well, ovarian cancer is terrible, let's invest in ovarian cancer, but it may be that understanding something about how DNA is repaired may be more important, and I'm using new facts here to inform that specific suggestion. Someone's holding in the front row a sign that says to me, overtime. This is not a football match, you should not be more excited by that. We have to acknowledge that we've reached the end of the hour. Other speakers are lined up behind me. Thank you very much for your attention.
This has been a presentation of the Library of Congress. Visit us at loc.gov.